Hey everyone, Will here. Welcome back to another video. This is for me personally, but it's also going to go out on the Ava Technologies YouTube channel, on our LinkedIns, because I'm here with Matt, who joined me the other day for a video where we did our regular show where we're talking about the news, and he's joining me today because besides doing these videos, we do actually do some work, and we do a lot of good stuff within the AI world. And we've recently been making leaps and bounds of progress within a particular space of the AI world, which is the self-hosting of models, running them on your local device, as well as how we can fine-tune small models to do better, and also host those on separate instances in the cloud. So we're going to talk through one of those. I want to start particularly with the local on-device models, which is coming up right now. Right, jumping in for a chat, as I said, I'm going to share my screen because there is something to demo first, and then I'll let Matt take it away because this is his hero here to talk about. So what I'm going to do is I'm going to restart this video and I'm going to play it, and then over to you, Matt, to talk about it.
Yeah, I'll kind of walk us through it, but in the video here, you can see an initial conversation here, and this is with a local AI model. So this is on the literal phone that you're seeing in this recording. And in this case, the model's kind of framed with being an AI therapeutic advisor. And you can sort of see a little bit of an idea of how the conversation begins to flow. Now, I think off the bat, it might not be obvious from this recording, but this is all running on device, and I can't state just how cutting edge that kind of is. I mean, it was only literally like a year ago, Will, that you and I were talking about the potential of AI models running on a mobile phone, and 12 months later, here we are. It's literally happening right in front of our eyes.
Absolutely. So let me get this straight again, just to clarify what we are watching here. This AI model here, because at the face value, the video could be deemed, to be frank, kind of boring. It looks like a ChatGPT interface, but I think the key detail, as you're saying, is behind the scenes here. That this model doesn't talk to an API or another service. This is literally embedded on your device. You can have no internet connection. It's not syncing it anywhere. Is that what this is?
That's exactly what it is, and having tried out a few different frameworks and libraries, all of it really cutting edge stuff over the last couple of months, I think this is the first instance where I've seen something potentially stable enough for you to kind of launch into a full-time app. And a lot of credit does go to a team that's put together llama.rn, which is effectively a port of another very famous and well-known library called llama.cpp. At the risk of getting rather technical here, it's really cool.
Get technical. This is technical.
It's really cool to kind of see this coming forward, really.
Yeah, absolutely.
Yes, it all sort of started coming together over the course of last week. I was actually waiting on a different library altogether to sort of mature enough with its own kind of solution, but in this case, I think llama.rn is looking like a good kind of head runner. And yeah, you could kind of see the result there in that recording. But it's really great having that element of privacy. But
it's amazing. So again, just to understand how this technology works, obviously I'm familiar with llama.cpp. That's a very, again, to the metal kind of framework for running local models. And then, as far as I was aware, the space allowed you. There have been some developments for running local models, specifically on iOS devices or specifically on some Android devices. If I understand correctly, the challenge with this is a bit like the days like pre-computer driver, where you had to specifically use software that played nicely with your hardware. And it's sort of the same thing with AI models at the moment. Is you have different types of GPU. You have the Apple side of silicon, as well as NVIDIA, AMD. There's a bunch of different hardware, and you have to be able to run it to support those hardwares. And if I get this right, this is another layer of abstraction that allows you to put this within. I believe this video is a React Native demo, so that means we can actually deploy it. We can actually deploy it to iOS and Android from the single code base. So that's how this works. Yes.
Yeah, primarily. I mean, there are definitely a couple of other options too, which allow you to just directly build for an Android phone or an iPhone. But there is something very powerful about having what's called cross-platform development, and that's kind of where llama.rn fits the gap. And like you say, it does then utilize React Native to help you facilitate it. But you do kind of touch a really interesting point about suiting the correct hardware needs. And I think that's a major challenge that's only really, again, kind of come out in the wash in the last year or so, where models are becoming useful enough at a small scale for you to then warrant the time and energy of getting one running on a mobile phone.
Yeah, I was going to ask you, what model is this running? What model is in the background of this video here?
To be fair, so I did quite a few recordings yesterday. I've got a feeling this one is Qwen free, but it was one of maybe about 10 different mobile models that I was trying out. But I think this one was Qwen free. Quantized, which kind of just means that it's reduced in precision, but usually you can get away with a lot of quality regardless of that lack of precision. But
do you know what parameter count this is as well? Because this is, I think this is what's quite instructive for me. Is obviously one of the big technical implications and one of the big things holding it back from running on your device is the fact that these models need humongous amounts of compute to run. So whatever you have running on your device, it has to be small by nature.
Yeah.
So this must be a small model.
Yeah. This is a tiny model. Of the variety of the 10 I've tried, they all sat within a 0.6 bil to a 1.5 bil. Again, I think this was
very
a Qwen
small,
free, so I want to say 1.5, but yeah, very small.
So very, very small. I think that leads on to an interesting conversation there then, that the use case for this, I mean, it's obviously very exciting to see this now being deployed, onto phones and usable like this. But I think this, obviously, you have to be honest with what that utility is. At a very small size, it's got to be used for very specialist things or very simple tasks, right? A 1.5B model, is just about capable of some sort of sentient conversation. So obviously there's going to be some limitations there. What sort of limitations are we looking at, and what do you think the solutions are, like moving forwards if you need something slightly more complicated?
Well, there's certainly two things that are on my mind. The first step, of course, is just optimizing how you use that model. And I think you touched a great point about where utility might lie. A simple chat like this one isn't using a ton of context off of the start. There is going to be a point where that conversation begins to devolve and the phone's going to get very hot. So there are limitations to that conversation. That's optimizing. So yeah, it's a case of optimizing how you use it and what for. I think there's also another area which I know you've been doing some research on over the last couple of weeks, which is fine tuning. And to be fair, I'm quite curious to sort of learn what you've pulled out over the last few weeks in that arena. Like where do you think mobile LLMs might benefit with fine tuning?
Yeah, I mean, that's obviously primarily where a lot of the research and development I've been conducting is within two things: embedding and then fine-tuning a tiny model to do better at one particular task, which has its pros and cons, which I'll get into. But then there is also the side of things where you can actually then start taking it, and you can self-host instances to have your own setup just in a cloud that you control. And then there is the benefit of then being able to smartly route between these different things, because again, like the small models, embeddings suffer from the same problems because fine-tuning is suffering from the same problems. They're usually very tiny models. I mean, I'm looking at models again along the size of 270 mil, the new Gemma model, which is specifically built for fine-tuning, as well as things like the Qwen 0.6B and models of that size. What you can do is you can fine-tune them, you can give them more data, you can do post-training to make them very good at particular tasks. So, for example, this is going to get technical. I've been doing particular research along fine-tuning the Gemma 270 million parameter model to get really good at executing Bash, for example. Now, you may or you may not know what that is if you're watching, but it's a very specialist task. That's the key point here, and that is the limitation that you have to be aware of, is that you might need multiple tiny models, all specialized into different tasks, strung together and routed together to be able to carry out a wider task effectively. But what that means is that you can run a lot more locally, and you can run a lot more with less hardware. So that
from a high level view, then it sounds like fine tuning allows you to really narrow individual sets of tasks that it could be good at, whether it's trying to write commands for a terminal, which is what Bash does. Or I suppose in another case, going back to our demo earlier, do you think it's going to be good for fine-tuning a conversation of, say, with a therapeutic advisor?
Yeah, if you had a particular data set that was geared towards question, answer, message, reply from between client and therapist, for example, you could run that conversation through a fine-tuning process that a small model could get really good at replying like that. And that is the key. So there's an element of experimentation with it. We have to try it and fine-tune the fine-tuning process to get the most effective results out the other side. But yes, that's one of the big benefits. One of the downsides is it becomes far less generalized. What you're watching on the screen there with like a 1.5B model is obviously I guess what you've done with that is it talks like that because of the system prompt, yes?
Yeah, it's got some system prompting in the background to sort of guide its more general knowledge.
So therefore you could then adjust that system prompt to get a different style of output, which, as you fine-tune these models, gets less and less capable, especially these smaller models. So that'd be one of the downsides, is that you fine-tune this model to be really good at one task, but that is the task that it's set at. So if you have multiple layers of tasks, for example, another part of what we do is working on a coding agent where it has to write commands. So that's where the execute bash comes from. But it also then has to be able to read files, write to files, and for this to work appropriately, you need to have some sort of model routing baked into the system architecture that allows you to use this small model for executing bash, and then use this small model for making particular fine tunes to files, and so it scales up the complication of the system underneath, which is what becomes quite complicated. But the power of it is really good. It means you can run all of this locally, or in theory, you can run all of this locally. You don't need to have cloud inference.
And it also, I suppose, highlights the point that, especially for specific apps on a mobile phone, you won't have a need for a completely general knowledge model. In the case of having a therapeutic app, it only needs to know a niche of its entire general knowledge set. So there is value in fine-tuning anything out of it that might distract it from that task. But in the same breath, like you highlight, if you have a need for it to have another domain of knowledge that it's knowledgeable on, then it might just be worth having two models that the app is capable of loading based off of the task that it's fulfilling.
I think
you go.
I think what will be quite interesting is obviously now we have a running model locally on phones. It's obviously then trying to find the most suitable model for the job, and this is where the two areas of research can combine. Obviously, you're using base models that the weights are available to use within the application. What the next step I would see is then taking one of those base models, for example, a 0.6B or a 1B or as small a model as possible, and running it through a fine-tuning process so that you can get more bang for your buck, if you like, and that you can get more predictable quality answers out of a smaller model, with obviously, and then get all the benefits of the hardware acceleration there.
Yep, I think you're absolutely right. And I think once we've kind of established a good fine-tuned model, that then gives us maybe a bit of a legway to understand what the limitations of different mobile phones might be too. Because I know we need to consider the differences, for example, between what a standard, say, iPhone 13, 14, 15 upwards are capable of compared to a lot of Android phones that might be on the market. And a lot of the kind of what's come out of the trial over the last week or so with this new cutting-edge approach does seem to lean onto iPhones being an easier piece of hardware to run these models on, but that doesn't rule out Android either. But I do think there's going to be a bit of a synergy between the need for us to potentially fine-tune and research models, but also see how well they behave across these different devices, these different bits of hardware that we want to support as well.
Yeah, and running environments, again, for example, like a Qwen Coda 30B model runs and behaves incredibly different depending on what provider you're using it through. If you're running it through a Llama on your computer, the quality is nowhere near as good as if you're running it through Llama CPP, for example. So there is a lot of experimentation and R&D to get this working optimally for
Yeah.
people. Just because we have one working example, right, doesn't mean that
Yeah.
it's ready for production necessarily. And that's what's fascinating is it's a continual learning trajectory at the moment.
Yeah. Yep.
Cool.
Cool.
I think that's probably a good summary. If you would agree.
Yep, I think that's a good wrap point. I think it would be exciting to catch up over the next couple of weeks together and share with everyone where our research has sort of led to next. And
Sounds good.
we certainly have some ideas of where that could go.
Yeah, no, absolutely. So yeah, thank you for watching. Hope you enjoyed, and we'll catch you in the next one.
Cheers.